Welcome back. Here's number 5. We'll be using our graphing calculator again, so have that handy and ready to go. If you're with us on the last problem, you'll see that this one is very similar to our last problem. So a woman looks out a window of a building. She is 94 feet above the ground. Her line of sight makes an angle of theta with the building. The distance in feet of an object from the woman is modeled by the function d equals 94 secant theta. How far away are objects sighted at the following angles? So if we're looking at how far away, we are finding d. So we are given theta values. So here's a theta value. Here's a theta value. Our job is we're just trying to find out, well, what is that d value? So I just can plug in 25. I'm going to find out what d is. So we'll head back to our calculator. We'll head to our y equals. You'll clear out, this is the last problem we had. And we're going to put in 94. Now again, there is no secant button, but you can do 1 over cosine. So I close off the parentheses for cosine, then I'm going to close off the parentheses because I wanted to group 1 over cosine together to make that secant. So that's what representing that secant is. So 94 represents my amplitude. 1 over cosine of x is all grouped together, and make sure you put double parentheses at the end. My window, I still have my window set up for degrees. I'm also in degree mode, so if this is the first video you're watching, make sure that your mode is in degree mode. You can pause here and change that. Now we get down to our y min and y max. Now my amplitude is 94, and remember these secants and cosecants, they're going to go up to infinity, so they're going to be above 94 for sure. Well, maybe I want to just look at negative 100 to 100 and see what that looks like, because my amplitude is 94. I'm at least getting to 94 before I start those horseshoe curves, and we'll count by tens. So let's try that window. And this window isn't going to work, so don't worry if you're falling behind on your calculator. I'll just show you what 100 to negative 100 does. So there's what we see when we do negative 100 to 100. So we can see where 94 is. That's the tops of those curves and bottoms of those curves, but we're not seeing much else beyond that. So we're going to adjust our window. Definitely not enough to go from negative 100 to 100. So we're going to go from negative 1,000 to positive 1,000. And we're going to count by 100. So now you can pause the video if you are using your calculator and find this window. And then this will give us a nice picture of this secant graph. And there it is. So you've got your horseshoe curves given right there. Now I'm going to use the value, so I'm going to find out what's her 25-degree angle, how far is the object 25 degrees of her vision, and then 55. So I'm going to use the value function. I'm going to go second, calc, value. You can tell your calculator, here's the theta value I want, 25. Hit enter. If she's looking at something at a 25-degree angle, that means that it is 103.7 feet away. Doesn't say what to round to, so we'll round to the nearest tenth. 103.7 feet is how far away that object is. To do the 55-degree, we'll go second, calc, we'll go value, and then we'll hit 55. Hit enter. At a 55-degree angle, an object would be 163 feet, 0.884, so about 163.9 feet away. So very similar to problem 4. If you want to see how to calculate these theta values differently, you can use your table, but I like using the value. You just hit second, calculate value. You can type in any angle that you want, and then you'll get your output, which is your distance. That would be your D. So again, your two answers, 103.8, 163.9 would be your object's distance from that woman's sight.